So hello friend, this is Kaustu Patare again with a new video. Welcome to our channel Making Maths Easy. So in the previous video I have solved one complicated sum based on implicit derivatives or derivatives of implicit function. So today in this video I am going to solve the another sum based on derivatives of implicit function. So please watch the video till the end in order to understand the sum. So let's start the sum. So we have the following function as e raised to x minus y, which is equal to log of x divided by y. So in we know that the in implicit function that both the variables such as x comma y is equal to or the function of x comma y is always equal to 0 in this case. So let us consider a particular function as an implicit. So x comma y is equal to 0. So first step is to take the derivative on both sides. Take derivatives on both sides. So after taking the derivative on both sides, you will get dy by dx or d upon d of x of e raised to x minus y is equal to d upon d of d upon d of x of or d upon dx of log of x divided by y in this case. So x upon y. So now we have to differentiate using the rules of differentiation. So first I will differentiate e raised to x function and I will differentiate x minus y function. So let's start. So first of all I will differentiate e raised to x minus y. So the differentiation of e raised to x minus y is equal to e raised to x minus y into the derivative of x minus y. So x minus y, and which is equal to, first of all I will differentiate the log function and then I will differentiate x minus y function as a loop derivative. So it will be 1 divided by 1 divided by, as I know that the derivative of log of any number or log x is equal to 1 upon x, so it will be 1 divided by x divided by y in this case into the derivative of or d upon d of x upon y function in this case. So first I will differentiate the log function and then I will differentiate x upon y or x divided by y function. So here it is e raised to x minus y. So I will write it as it is and then I will differentiate the x and then I will differentiate the y. So the derivative of x will be equal to 1, whereas the derivative of y will be equal to 1 into dy by dx, which is dy by dx. As I told you in the previous videos that the derivative of y with respect to x is always equal to dy by dx. Always remember that derivative of y with respect to x is dy by dx or 1 multiplied by dy by dx, which is same as dy by dx, which is equal to, this y will go in the numerator, so it will become this y will go in the here in the numerator and it will become y upon x in this case. So it will be y divided by x and then you have to take the derivative or differentiation of x divided by y. So you have to use the u upon v rule, which I have told you in a previous video. So u upon u into derivative of v minus v into derivative of u divided by v square. So this formula you have to take, you are taken into the consideration in this case. So the formula is as follows. So first you take the uv, so v into the derivative of u, so d upon d of x of x minus y into the derivative of this function. So y into the derivative of x into the derivative of y in this case divided by y square. So now we have done. So now we have to express it in the form of dy by dx. So it will be write it as it is, or we can multiply this e raised to xy inside the bracket. So after multiplying it, I will get this, and then dy by dx. So e raised to x minus y minus e raised to x minus y dy by dx, which is equal to y divided by x. 1y we can cancel here, 1y, because here it is y square in the denominator and we have a single y, so we can cancel it, and this also, this y will also get cancelled because y upon y square is equal to 1 upon y, so we can cancel one y in this case, and we can write 1 upon x in this case, and then we can 1 upon xy in this case, and then we have to differentiate this function. So y, the derivative of this function, we can also write, we can directly write the derivative. So the derivative of this dx upon dx, or derivative of x, is equal to 1, so I will write 1. So no need to write, we can also write here dot 1, so no need to write. And the derivative of y with respect to x is dy by dx, which I have written over here. So now we have to multiply this 1 upon xy inside the bracket. So after multiplying inside the bracket, I will get this, I have to write it as it is, and which is equal to 1 upon 1 upon xy multiplied by y. So here I can cancel one y, so I can write here as 1 upon xy multiplied by y. So y will cancel in this case, as I am multiplying and dividing the y, so in this case y will be cancelled, so it will be 1 upon x, and then here 1 upon xy I will multiply it with this function x into dy by dx. So in this case x will get cancelled, so I will write here as 1 upon y, because x divided by x gives me equal to 1, so I will cancel x, and then I will write my dy by dx in this case. Okay, so now we have to take the dy by dx terms on one side and other terms on another side. So for taking it, first of all, this e raised to xy we have to write it as it is, and then this 1 upon x will go on the left hand side, so it will be become minus in this case, and which is equal to, and this minus e raised to x minus y dy by dx will come in on the right hand side because it is a dy by dx term, so it will become plus. It is minus gradually, but it will become plus in this case if I will write it on the right hand side. Okay, and this will remain as it is because we are not changing the term. So now we can take dy by dx common in this case. So for taking this dy by dx common, we write here, and then take dy by dx as a common, and then put a bracket and write e raised to xy x minus e raised to x minus y minus 1 upon y, and then close the bracket. And then we have to do one thing, divide this function divide this function by this, divide this function by this, and we can calculate the dy by dx. So my dy by dx, or the final answer, will be equal to dy by dx equal to this function divided by this function. So this will be a final answer. You can also make it in the simplest form, or you can also elaborate, or you can also simplify the answer. If you need to simplify, you can keep it as it is, no change, no need to do the change. If you want to change, you can change it. So in this way you have to solve most complicated sums in the mathematics, or derivatives of implicit functions. So now I am taking a leave. So if you like my video, please share, subscribe and comment on my YouTube channel, Making Maths Easy. Also like my YouTube videos, and also share the videos to your friends, so it will help somebody to score good marks in the examination. So I'm so thank you for watching.